Yeah, welcome back to the lecture. Now we want to talk about biofilm reactors. We have already learned how to apply biofilms in wastewater, what are advantages, disadvantages. Maybe we have to carry with mass transfer, we have to control the biofilm thickness. Yeah, mass transfer important, maybe energetic questions. And now we want to come how we can apply biofilms in reactors, which are used in wastewater treatment. Yeah, I will make me small again. Yeah, we want to talk about trickling filters, which is a very old process, older than the activated sludge process. We will talk about rotating disc contactors, moving bed processes, fixed bed reactors, also called biofilters, and fluidized bed reactors. Yeah, first we want to make a small characterization of different biofilms. Here's the so-called ground biofilm. Now this is the biofilm we have talked in the theoretical part. This biofilm is thin, high performant, irreversible bound, but slowly growing. We had also an adhered biomass. Also this is the case if you have a post-connected biofilter after an activated sludge plant. Finally, there the activity is fast available, also for nitrification, for example, but after washing you have a loss of activity. And we have packed biomass. There we are using support material with a high porosity, like in a moving bed or fluidized bed process. We will see some examples of this. Yeah, the oldest part of wastewater treatment is the so-called trickling filter. The idea came up from the land application of wastewater. The people observed if the water is not infiltrated permanently with some breaks, the water quality, in this case the groundwater, was better. And this was due to the aeration, the effect that oxygen or air can penetrate. And to make this a lot more precise and effective, they are constructed trickling filters. Also like in any wastewater treatment plant, you first have a primary sedimentation to remove particles. And then with the pump, the water is even distributed to the surface of the filter and then trickled through the filter material. This is a three-phase media. Inside the filter material there's as well air. And to ensure an even load, surface load of the trickling filter, there is a recirculation constructed. Now you need also this surface load to make the control of the thickness of the biofilter. And therefore, due to sloughing, particles are removed from the bed and flushed to the secondary clarifier. There you have the effect that the sludge is brought back to the influent. And from the primary sedimentation, the excess sludge is operated. This principle you will observe in many slides that I have taken from Willy Guya. And I asked myself why this is done. Is there any reason? And there is a reason. I think the reason is that this sludge from trickling filters has a quite well absorption potential for organic components. And finally, if it's mixed with the influent, there is already a removal of organic material due to absorption. And all this material goes to the excess sludge and maybe later on in a sludge digestion. Yeah, these operators could be quite big and they can be also filled with natural materials like stones, for example, and they need, of course, because of the heavy weight, a very potent support media where they are installed. And this can be done also quite primitively from concrete, This only has to be ensured that the water can percolate through without resistance, and the air also can pass in the direction from the button upwards. Yeah, in trickling filters you don't only have biofilms of bacteria. In this environment, moisture and warm other organisms like to live, like insects, and here you have the fly of the materials. And if you are not operating very, very well, maybe you have a pest, millions of these flies, which could be bothering the surrounding people. Therefore, normally the walls are washed and so on. Also, other animals can enter, like snails that likes to eat biomass, biofilms. And they are really hard to get rid if you treat the water with chemicals or extreme pHs or what. They are going back in their house and make it close, and if this is over, they are coming back again. Yeah, normally you have profiles in the biofilter. The typical from textbooks is the upper part. First the BOD is removed, and then there is the nitrification take part in the downer part. Yeah, how to design a trickling filter with chunks. This is not so easy. Yeah, finally you have the load for the volume load of the material given as the BOD load, also the volumetric loading in grams BOD per cubic meter and day. And, you have the typical values, and typical values are 400 gram BOD per cubic meter and day for BOD removal, and 200 BOD per cubic meter for nitrification. These are values of experience, and if you know this, you can finally solve to the volume of the trickling filter and make a proper design. Yeah, here is given an example of a trickling filter in Bolivia from Holger Papsch, former colleague. He is working, owning now a consultancy company that has to plan and build a wastewater treatment plant in Sucre, the capital of Bolivia. You see, it's a quite dry area, hilly, maybe remoted. Yes, and what they want to use as a material, you see these reactors are quite big, they are not really small, and you see there are not so many stones available. And finally they have to bring the material from Germany, and to bring very high-tech packaged material in this volume, this would be also very expensive. And so they decided to use these plastic strips. They can be transported very compact, and then they are installed on a special hardwood like this, and then the water trickles around this material, and after a while a biofilm has formed. As well in Hamburg, one wastewater treatment plant, but the municipal and industrial wastewater treatment plant uses this material. If you're using special designed plastic packings for the trickling filter, then you may know the specific surface. As you know how much surface per volume of the packing material you can use. And then you can design the surface loading of the packing material, and you can calculate so the volume of the trickling filter. The surface loading is how many grams BOD per square meter and day you can provide. The advantage is that you can easily make as well lab experiments with your wastewater to find out what is the potential. The typical values are 4 grams BOD per square meter a day for BOD removal. Also this is the same if you have 100 square meters per cubic meter for the load for the chunks, or vice versa 2 grams BOD per square meter in nitrification. Also finally you need at least a specific surface bigger than 100 square meter per cubic meter. Yeah, also here are some photographs. Also a typical material used for high-tech filtration. You have a cross-flow media. Also finally a media where the water is better even distributed than only due to the sprinkler. And later on there is a vertical flow media where you have a very defined surface area and where the hydraulic resistance time of the water is also more or less the same in every part. And this is also not easy to ensure. Another option is if the air is not passed due to normal recirculation, you can also install blowers to ensure the oxygen supply of this maybe high-tech trickling filters. And these blowers are lower energy consuming because the pressure loss is very low in comparison to the aeration of activated sludge plants. Here you see also a long arm of a trickler. This is a hard job. This is a photograph of an industrial trickling filter. It's quite warm water. This is also an advantage if you have to treat processed waters with quite high temperatures. And this maybe is also an option because you have also a cooling down in the trickling filter if the ambient temperatures are cold, of course. Now let's come to the contactors. These contactors are mainly used in small size wastewater treatment plants, as if there is not a sewerage connection, for example, then maybe some neighbors are together operating a wastewater treatment plant, but as well in industry they have also a primary clarifier, and then they have these contactors. These are drums. Here you see they are filled with packing material, and they are sometimes out of the water, sometimes inside the water. The advantage is that you have aerobic zones and anoxic zones, and if the speed is adequate chosen, then we have in the reactors nitrification and denitrification. But as well, some particles are coming out, therefore we need a secondary clarifier before the water is discharged. And here also the sludge is brought back to the influent to make use of the absorption of this sludge. You can also go ahead for a rotating disc contactor. The disadvantage is that you can calculate exactly the surface of an apparatus like this. All parts are available for the wastewater, therefore everywhere a microorganism can live. And they are also particulate in the water, and they have oxic phases and anoxic phases. I only have heard from one of these plant operations in a municipal wastewater treatment with a very special wastewater in the only high sea island of Germany, Helgoland. And there are every day coming 20 times more tourists than inhabitants, and they like to eat fried fish and fried potatoes. And so there is a lot of oil and grease in the water, and so they decided to make a quite safe system to treat this water. But anyhow, you see the same setup. you have a primary sedimentation, secondary sedimentation with the return sludge in the influent, and here you can control the biofilm thickness as well mechanically, and so there are no blocks as possible. I have not so good photographs, but there are also quite big installations of this rotating disc contactors available. Yeah, the rotating disc contactor you can design by the surface loading. Also you have here this, the surface, you can count the number of discs, and then you can calculate the surface multiplying by 2, because you have here 2 sides. Yeah, typical values are 8 to 12 grams BOD per square meter, and they for BOD removal, and 4 to 5 grams per cubic meter for nitrification. If you remember, this is a lot higher than in trickling filters with this packing material. And this is also due to the fact that here you have the access to the biofilm easily and everywhere, where in technical apparatus like trickling filters, some areas get more water than others. Now we are coming to the moving bed process, and we see one material which is used for the so-called packed biomass. Therefore you see, finally this material is just round about 1 centimeter in diameter. This has also a bigger surface for the outer side and protected areas inside. And they are constructed for the removal of soluble components. A company that invested one of this material was Kaltness. It's quite expensive, and now there are other companies that are making something similar. The only difference finally is that the starting up phase with this Kaltness product is faster than with the other materials. Normally they are used to bring an activated sludge plant in action, or if you have problems with the sludge, like floating sludge or what else, then the people, or mainly industrial utilizers, are tending to use this material. So finally this is new, and after a while you see 10 centimeters and 7 millimeters, 10 millimeters and 7 millimeters. This is quite nice material. The challenge is to keep the material in the reactor, mainly even distributed. Finally, if you remove the water to the overflow, then you see the material is accumulated there. This is mainly like a filter fixed bed in this point. And it's quite hard for as well living suspended biomass to pass through. Therefore, there are some sieves installed to have a big surface to remove the water smoothly with not big flow gradients. On the other hand, here you see also an advanced aeration system. Finally, you have a high performance, and you need maybe also a good oxygen transfer inside the system. They are used very successful in the paper industry to treat the water. Now we are coming to fixed bed reactors, biofilters. Here is a schematic view of a biofilter which was flown from water and air from the bottom to the top. Normally you have also then concentration profiles over the height, like in the trickling filter. And finally you have here these particles with the biofilm. But sometimes you have also areas where no water can go through. We call this stagnation volume. And finally the gas bubbles are held back, they are growing, and then they are floating and renewing itself. And for this reason we have a very excellent oxygen transfer in reactors like this. And here is given as well a sketch to the biofilm from the support material. The oxygen is depleted. Maybe the nitrate is also removed if there is sufficient COD. Ammonium is degraded if there is oxygen. And there are many things possible with these types of reactors. But if they are operating as well as filter, you have to consider that you not only can operate in filtration modus, as like here for a typical filter, sometimes it's also loaded with so many sludge, and therefore you have to wash. And therefore this is, as the operation costs are quite low, you have quite high investment costs. Yeah, you can read this carefully. Maybe the numbers are changing due to time, but finally you have to spend also some attention to the washing, because this is crucial, because finally you're producing sludge, and finally after removal of the solids you have more water. This has to be calculated. Some plants are operating with 50% washing water, which is a notable amount, and then you have to prepare more filtration. Yeah, the filter material that I told in the last lecture as well, they should be grow on the material, of course. They should be ensure an even distribution of air and water. There should be mechanical resistance. If you're losing every week 10% of the material, it's not feasible. It should be allowed to wash, also good washable. You should be remove the surplus biomass. And if you want to operate as a filter, of course, there should be some separation of suspension. Yeah, the distribution of processed air is also a little bit tricky. Also finally, you have to be able to adapt to the operation conditions. Finally, you also need to distribute the air uniform through the surface. You don't want to have a jet ventilation. Also, you want to make use of a high oxygen utilization, and you want to make the energy requirements for this purpose as low as possible. Also, the aeration system should not be susceptible to blockages. And you have also to think about the effective introduction of purging air. Finally, for the washing process, you are using a lot of air as well to save washing water. Finally, you make a fluidization with air and a little water to bring the material in the water phase, and then you flush out with a high water velocity. Yeah, here's the setup. Normally they are using these two fluid nozzles, which are used also in the drinking water supply, and they have a hole here, maybe 2 millimeters, where normally the air goes through and the water goes through. And then there is another installation. If you need a lot more air, then this water level will drop and more air goes through this as well. Yeah, another thing is if your reactor is blocked, and then you may need a lot of pressure, and this leads to high cost, because all the reactor is a pressure vessel. And to overcome this, you can install special nozzles that are breaking the blockage, which are connected directly to the compressed air. So not the total reactor is under this pressure, only this nozzle for breaking the material. And if the material starts to move, then all the material becomes in fluidization and you can remove the biomass. Yeah, there are many processes on the market, from Veolia, former times Degremont, the Bio4 process, They are operating with air and water from the bottom to the top. They are using this mineralic media. They have also BioLite, they are calling this. They have an air distribution and an extra installation for the process air. Yes, and they are collecting water, and they have also a container for the wash water. Another process is from General des Eaux. They are making this different. They have a floating material, polystyrol. They have the nozzles at the top, and the water comes from down to up. And the thing is, for washing, this goes vice versa. And the idea is that you are able to aerate inside the packing material so that you can install anoxic zones in between. As I know, there's only one wastewater treatment plant operating in Germany from like this principle in Herford. Also here you see the material, also this originally white polystyrol balls, the 5 millimeters or something like this, are grown with the biofilm. And yeah, you have this nitrification zone, and above the denitrification zone you have also washing water. Finally you store the water here, and for washing you are pushing this back. A very important topic as well is the pre-treatment of the water for biofilters, because you want that they are not blocking, and therefore an effective removal of particles, and if possible COD is required. And normally this is done due to flocculation. Normally they are adding some iron salts or polymers, and so the material can sedimentate, and normally there are also parallel plate separators installed to enhance the quality. Yes. There are also continuously working filters on the market, and they were also used or misused for biological treatment. The Dynazon process. There the water is implemented somewhere in the middle and filtrated upwards, and then the clean water goes out. And the loaded sand is brought with the mammoth pump upwards and then washed with the flow out here, and then you have the sludge flow rate, and the washed sand goes back. And this is quite successfully used for industrial filtration processes, even though you have also up to 15% of sludge water, and sometimes this was also used biologically, also for nitrification, but finally with big aeration you have problems. They are adding hydrogen peroxide or something like this, or also for denitrification by adding methanol. But I say for filtration this is a good option. As a bioreactor, I personally have my doubts. Then maybe you can think about the design. Also this is the velocity, also the surface load of gas. This is the surface load of liquid, and here is given the parameter, the height of the reactor, also here the gas velocity, and here is the specific utilization of oxygen that you want to find out. Also if you are operating with 10 cubic meters per square meter an hour for the liquid, and here in this case with 15 cubic meter per square meter an hour gas, and you're having a height of 5 meter of the reactor, then you are utilizing a little bit more than 0.4 gram per cubic meter and meter. And so you can find maybe out a good operation point. Yeah, you can also combine biofilm processes with activated sludge. Also, if you want to separate the autotrophic microorganism, like nitrifiers, from the heterotrophic COD removals, then this would be quite complicated in an activated sludge process. But you can bring the denitrifying bacteria in a fixed bed reactor or trickling filter or biofilm reactor, and so you can have here a smaller sludge age, a higher load. And maybe you need some post-denitrification as well. This you can do as well very effectively with biofilm reactors, but you need an external C source. And nowadays, with very good control measures, you don't have overdosages anymore. Here I will show you also a picture of a biofilm wastewater plant operating with the Bio4 process of Degremont, Lyon wastewater plant. Lyon is a city in Switzerland, in the French part, famous for the Champions League, where they are voting or arranging the teams, maybe you know. The bioreactors are here. This is a total wastewater treatment plant. Don't look like a wastewater treatment plant, small footprint. And interesting, on the hillside, even though Lyon is a city located to the Lake Genève, but the plots at the coastal side, at the lake side, are very, very expensive, and so it's cheaper to buy the area outside the city and pump the water upwards. Yeah, this reactor consists of 8 compartments. You see they are aerated here for mainly nitrogen removal, and they are making phosphorus removal due to precipitation. In Switzerland, at least at this time, they had focused on the P removal because P is the growth limited element for the big lakes. The interesting part is always under, in the cellar of the wastewater treatment plant. Here you see the compressors for the supply of oxygen. 8. Yeah, here you see the material. This was emptied. And here you see in operation and in idle. Also finally, if you don't need the reactor for a time, it's not good to aerate. And finally, if there is no food and aeration, then the microorganism dying faster. And here there was also a parallel plate separator opened, also here in action. The water was removed, and you see that the parallel plates are constructed in this special form with 6 edges, hexagonal. Yeah, now we are coming to the fluidized bed process. Here you can use very small particles and realize a very big surface to volume ratio. Also as materials there were used activated carbon, broken sand, plastics, or even porous glass. You can also use so-called airlift reactor, where you have a loop installed inside. They are only aerated under the loop, and due to differences in density with the aerated part and the unaerated, a loop flow is formed. And then due to the special construction of the head of the reactor, you have the separation of the material which is not forced by the loop. Or here, this is also the main part Finally, the air is separated from the rest, and here is the sedimentation, what's going on. This can be combined as well with fixed bed reactors. Yeah, a very famous fluidized bed reactor is the UASB reactor, the upflow anaerobic sludge blanket reactor. Also here in photograph, and here's the scheme. This is mainly used for anaerobic treatment of high-strength wastewaters, also from slaughterhouse, sugar industry, starch industry, also these areas. And there the biomass is forming pellets. And finally the water is pressed through the pellets, they are sedimenting. Sometimes this needs some operation and they are adding flocculants, and then the biogas has to be separated from the flow, and they have these gas collection domes. Sometimes this is also in 2 steps to remove the biogas and also the H2S sometimes, which is not good for the anaerobic digestion. And yeah, this is quite successful, at least as a pre-treatment of high-stress wastewaters in this type of fluidized bed reactors. I hope that I could give you a nice overview over what this process is. I'm quite sorry that not all slides are completely translated to English. I will have a look to do this next time better. And then I wish you a nice day. Bye bye.